Greetings everyone! On the bench today is a car stereo amplifier. Kind of looked at it in the other video. It's a Carver brand. So I wonder if it uses Bob Carver's multiple voltage rails as my camera struggles to focus. I think it's these parallel lines. Some cameras don't like to focus well on that, so oh well. But anyway, so I'm not a fan of name brand stuff. You know, I've always been a DIY, do it yourself. Would I say DIY, do it yourself? Yeah, Carver. This was given to me for free. The guy sent me a bunch of electronic stuff. So, I just want to see if it works or not. Take it apart. See what makes it tick. So over here we have a screw terminals for the speakers, high level inputs. We have some switches, little twigulators there to adjust the sensitivity, input, and outputs. I guess you can connect amps together. So over on this side, where the power goes in, the electrons have to go in somewhere to make it work. Mobile power amplifier M-240, ground remote battery, plus 12 volts, Carver AGC20. Output power, 2x120 watts, RMS. And on indicator. So it's not very big. I mean, I don't have a big hand, but it's not huge. So I wonder if it uses Bob Carver's multiple rails to, you know, let the amp run cooler at a given power output. It was probably made before all that bass stuff was big, because you're playing continuous bass tones at a high level, so that would kind of nullify the well, not necessarily. I'm thinking of the heat savings, but an amp, you know, in theory gets hot out around 1/3 the power, or gets the hottest. So yeah, I don't know, maybe it does help. I have a fuse in there, that's good. Let's see what it says here. 32 volt, 30 amp. That's not a good sign. It's supposed to be 20 amp. AGC20. I guess that means it takes a 20 amp. So, might have a problem here with this thing. There's the bottom of it. It's just vented cabinet. I don't know why there's vents, because you bolt it up to a surface. You know, there's not a lot of room for airflow. But of course this is the heat sink. That's where it's going to dissipate the heat. Pretty typical design of car stereo amps. Has the big long extruded finned case, which is really the heat sink. Alright, well, I'll shut up and hook this thing up and see if it even powers on. Okay, I have power connected. I didn't connect the speakers yet, just in case there's a problem. I don't want to risk damaging my speakers. So we have a negative to the ground here and positive to the plus 12 volts, and also supplying the remote so that the amplifier turns on. I have channel 1 here at 12.6 volts, current limited to 1 amp, just in case. So I'll go ahead and apply power, and it pulls it down into current limiting. See, the light went red. 3.23 volts. It may not like such a low current. Let's crank it up. I'll just turn it all the way up. What the hell? Let's see what happens here. Okay, this is not looking good. Turned it on again. It's drawing the full current, and it still pulls the voltage down. It was in current limit. So, might be something wrong here. Let's try it again. Yep. I would think that that amount of current should fire this up, but it's pulling the voltage down. I might have a problem with this thing. Okay, I popped the top. I guess in this case the bottom. Yeah, it looks like your typical car stereo amplifier. You have a switch mode supply here, and looks like the signal and power amp section over here. So you got a little, probably a controller chip there, and the heavy wires of the primary side. So you got the thick red, the thick green, and the red and green tied together, center tap. So it's a half bridge configuration. See, the green wire goes to these 3 transistors on this side, and the red to these transistors on this side. And I can't really test these very well because of the low impedance. You get this 2.2 ohm resistor, so I can't use the diode test function on the meter. I'm getting readings I can't conclude are good or bad. Anyway, on the secondary side, you have these wires coming out. The thicker wires go to this bridge rectifier, full bridge rectifier. And thinner wires might be for op amp voltages. You have these chips here, probably op amps. 25 volt caps, because the op amps usually have plus minus 15 volts. And the larger caps here are likely for the power amp stage. And there's one on this side, one on this side. I can only see a pair of transistors, probably a NPN and PNP. I don't see multiple transistors. So it's just your standard output with one pair of transistors. And maybe bias settings, they got them glued. One thing though, I see these transistors here on each side, wires running over to the amp. So this might be one of these stepped voltage type deals like Bob Carver's known for. Yeah, I think I'm going to want to see if I can find a service manual or something on this, a schematic. See what I can come up with. Well, look what I found pretty easily. I just put Carver M-240 into Google, and it's the very first link. A service manual. Imagine my luck. Let me zoom in a little bit. I gotta hold the camera in one hand, so this is kind of a pain. So we got specifications here. Power output stereo mode. 120 watts into 4 ohms. They don't give you an 8 ohm measurement. With a stiff regulated supply, you get about 60% of the 4 ohm power. So it'd be around 75 watts into 8 ohms. And distortion here. One thing I noticed about Carver amps, they don't go for the real low distortion. You see 0.15. I mean, that's not bad. I question if you could hear anything close to that in music. Bridged 150 watts into 4, 240 into 8. Well, that's interesting because the 4 ohm rating is lower than 8. That tells me the power supply or the amp is struggling to deliver current into 4 ohms. That tells me do not use it bridged with 4 ohm loads. I don't know why they even do that. Seems like that would just roast the amplifier in quick time. Yep, 20 amp fuse, 11 to 15 volts supply, impedance, input impedance. And here's the schematic. Here's the power supply, and yeah, it does use double rails. It has a low and high rail, so you have your 20 volt and plus or minus 20 and a plus or minus 39 volt rails, and it uses what they're calling a commutator circuit, one for the positive side, one for the negative side. So when the circuit detects that the output waveform is approaching clipping when on low voltage, it turns on the commutator, or I should say it turns on the 39 volt, passes that through onto the output stage. So instead of having a stacked output stage, it just uses a standard output stage, 2 transistors in push-pull configuration, and it just turns on the higher supply. I mean, it still works the same because most music is not going to require the higher supply. It just runs it in the plus minus 20 volt mode and causes less dissipation. So only when it needs a large output, it turns on the higher supply. So they kind of have a block diagram here. See, here's the output stage. You have your plus 19 and negative 19, and the commutators connected to the outputs. And again, when it determines the voltage is going to go above what the plus and minus 19 volts, I wonder why it said 20 though, but whatever, it turns on the transistors in here and passes the voltage onto the output stage. So yeah, you can see the reason for all those op-amp ICs. You have an infrasonic filter on the input here, a low pass, and a inverter, so you can run it in bridged mode. Then an input buffer here to the amplifier stage. So yeah, that's why it has all those IC chips. This is something interesting I found here. Since the turn-on transient is 44 amps, the power supply must be rated for a minimum of 44 amps without current limiting. Both the current and the voltage should be monitored at all times. If the voltage drops below 7.5 volts, turn the supply off and restart. If the power supply limits during turn-on and the voltage folds back, which we saw in my case, the switchers may lock on one side and cause thermal damage to the switcher transistors. Q7 and Q12. Well, that's actually Q7 through Q12, as we shall see. This is not a problem with the SG3524B, and that's that switch mode chip. So apparently, earlier versions of this IC would latch up under low voltage conditions, and that's what's in that amp. I have the non-B version. So here's the power supply. Power comes in here, connected here at the center point of the center tap of the switch mode transformer, and these banks of transistors Q7 through Q12 alternately switch on and off for in a half bridge configuration to switch current to ground. One side's on, the other side's off, and then it alternates. There is some dead time, of course. Look on the base of these switcher transistors. 2.7 ohms. Very low value because you want these operating as fast as you can. This is the 1980s. They're not using MOSFETs in the switch mode supply. And you need to drain the charge out of the base of these transistors, so they use a very low resistance there from base to ground. I don't know if you can see that. It's upside down, but I don't have the B version of the chip, unfortunately. So my supply obviously doesn't provide that 44 amp transient or whatever it said. But I can parallel the channels together, and service manual says to run it at 13.8. So I'll get 13.8 volts in the sum of these two currents, so 6.4 amps. But when I turn it on, of course there's capacitors and stuff that might give me a little bit of power here, or surge current. Let's turn this on. Look at that, it stayed. So I think we have, little LED is on, I can see. No current limit, it's only drawing 400 milliamps. You have to sum those two. So yeah, it turned on now. So that's a good sign. Let me check the outputs for DC voltage. And if it's good, I'll hook the speakers up. Okay, got the speakers hooked up. Input source going through the preamp from the music player. You can hear that clicking sound from the last video. That's coming from the wireless router over there. But let's play some YouTube safe Russian dance music. Okay, hopefully I wasn't clipping the preamps in the camcorder here. But yeah, it's working. Probably would be a good idea to change that chip out for one that doesn't have that latch up issue. Though in normal use, it shouldn't be a problem. It's just that on a bench supply, if you don't have enough current, you may not be able to boot the thing up. But anyhow, I'm kind of curious of the power. I saw somewhere it said 74 watts into 8 ohms while reading the service manual there. And of course my supply here is not going to be able to provide enough current to test it, but I'll try one channel at least anyway. You can only do one channel at a time. Well, before I do the power measurements, I'm just checking some voltages here with the meter. So, the amp supply, this line comes over here, and that's on the same trace. That blue wire, minus 19 volts. If I come over here, catch this positive, or the red wire, that is plus 19 volts. So the amp is getting its proper voltage. So let's see here. If I measure this side of the rectifier here, I get 38 volts, 38 and a half. And this other side, if I can get in on it, is the negative 38 volts. So the both the rails are doing their job. So let's take some measurements here. Let's check the power. Hopefully I can even do that with my limited supply. Okay, I'll use this as a load, 8 ohms, non-inductive. Only going to test one channel because I just don't have the power here. I'd have to have a car battery or something backing me up. Let me get you pointed at the scope. See what we can do here. Crank the thing up. Something. Yep, my supply is going into current limit. If I do it quickly, maybe I can see how high it goes. Or I can just stop at the point where I think 17.29 volts. Let's see what that is. Turn that down. Don't want to get my resistor too hot. 37.36 watts, so I'm a far cry from the 74 watts. And again, it's not the amplifier, it's the limit of my supply here. Well, I can try adding this battery. It's not in the best of shape. It's from 2013. But, you know, anything will help here. Let's see what happens now. Oh yeah, a little bit of rail sticking. But it is going much higher. At that level, my voltage drops to 11.86 though, so we're not getting the full recommended voltage to the amplifier. Let's see here. 21.2 volts, we'll say. So we're getting 56.2 watts. That's better. Yeah, I'd think the amp could do 75 if I had the proper way to supply it. But I just don't have that with my bench supply. So now what I want to do is show you how that commutated supply voltage works. So I'll scope the output waveform and the supply voltage. So the pink line is the supply voltage. So you can see when I put that on, it goes 20 volts up. So that's the positive rail, and 20 volts down is the negative rail. So the amp's staying on the 20 volt supply, and as I crank that up, approaches clipping. Just before clipping there's a little headway, so it has time to work. But see, the peak of the signal is getting so close, so it turns on the high voltage supply, which was around 39 volts. Well, it's a little bit less if we can't get that high with our supply. But you can see now it has room to work. So the waveform doesn't clip earlier. It has that working headroom now. So let's turn that back down and go on the negative rail and do the same. And it does the same thing. So it's working just fine. So this amplifier seems to be working okay. I'll check the other channel to make sure it's triggering the commutator to deliver the higher voltage supply as well. But I think will probably be okay. Like I said, it might be a good idea to replace that chip if I can find the B version. Though with the proper supply, I think it'd work okay. What do I think about these amps? Yeah, I'm not really a name brand type of person. And the amp does what it's supposed to, but you know, there's just all that extra components to make it do what it has to do. You know, it has that commutator circuit. That's just more potential point of failure. Though it does help the amp run cooler. From the video where I was testing that Carver PA amplifier, I was getting some people saying how great Carver is, and then other people saying they're pieces of unreliable junk. I don't know. I don't have a horse in that race. To me, this stuff is just electronics. Like I say, I got it for free. It's fun to make a video of it, and that's really all the interest I have in it. I don't really have any use for it. And this is not swollen. It's just the plastic cover bulges up a little bit on these. They're okay. Well, I guess that's all I have to say on this one. Thanks for watching.